Volume of pyramids and cones. So a pyramid is, well, you've all seen a pyramid before. The volume of any pyramid is 1/3 the volume of the corresponding prism. So if you can see here, I have a rectangular prism and I have my pyramid that lives inside of there. If I was to take that pyramid out and fill it with water, I would have to fill it with water 3 times for it to fill that whole rectangular prism up. Which is why the formula for the volume of any pyramid is given by volume equals 1/3 AH, where the A, once again, is the area, but it's now the area of the base. Okay, so the A stands for the area of the base of your pyramid. And here I've got a couple of pyramids. Here, the area is a rectangle. This pyramid, the area of the base would be a triangle, and this one, the area of the base looks like it's going to be a square. And once again, looking at our trusty reference sheet, the volume of a cone is hiding right here. Volume equals 1/3 area times height. So this gives you the volume of a pyramid, and I know I just said cone, and a cone. Okay, and the reason we use this formula is, or the way we know it, is a pyramid comes up to a point, as does a cone. It comes up to a point. This is a very bad pyramid. Okay, so because we're coming up to a point, we're going to use this formula. And remember, for a cone, the area of the base is a circle, so the formula for the volume of a cone simply becomes 1/3 pi r squared h. But you don't need to memorize it because it is here on your formula sheet, and the area of the base you all know is a circle, and you know this area of a circle is hiding here. You can see it on your formula sheet, or here on your formula sheet. It's hiding in 2 places. I hope that helps. So now how do we use it? Well, let's look at some examples. It's pretty easy. Volume equals 1/3 the area times h. V equals 1/3 AH because it's a pyramid. I know a pyramid comes up to a point. 1/3 the area of the base, well, luckily it's given to us, it's 45. And the height, like in rectangles and triangles, we're looking for a height that's making a right angle with your base, and in this case it is 7. So completing this, my calculator gives me 105 centimetres cubed because I'm looking at volume. This grain bin, question 2, this grain bin has the shape of an open square pyramid. How many cubic metres of grain will it hold? Well, we write our formula out. Volume equals 1/3 the area of the base times the height. So it's 1/3 times, now we know this base is a square, so here is my square. The area of a square is length times breadth, so 2.5 times 2.5, or side squared. And we have to remember the height. The height of the pyramid is 1.8. So if we pop that in our calculator, we get 3.75 metres cubed. So that was nice and easy. Now a cone is just like a pyramid, except it has a circular base. So if we use that formula, volume equals 1/3 area times height, the area now can be replaced with pi r squared because that is the area of the base. So this comes from a cone fitting inside of a cylinder. So if I imagine here's my cylinder and I can fit a cone inside of it, and just like that pyramid question above, here is my cone living inside a cylinder. 3 of those cones would take the volume of that entire cylinder. So this is not on your formula sheet, but if you know the formula volume equals 1/3 area times height, you can find the volume of any cone. And here are a couple of cones, the base a circle, and my height the base of the circle, and my height. So let's have a look at this example. Billy the plumber, he dug a rectangular trench, and here it is. And this is more a problem-solving question. And it's 1 metre by 0.8 metres to lay some gas pipes. He ended up with a conical pile of dirt. So here is my dirt. Conicals are just like a cone, and which has 1.2 metres high and has a radius of 0.5. And says, how many square metres of dirt, correct to 3 decimal places, did Billy dig out? So when I'm talking about how many square metres of dirt he dug out, this really should say how many cubic metres. So we can cross that off. So we're looking for volume. Volume equals, now we can't find the volume of this original trench because this has this letter here, but I can find the volume of this cone. So volume equals 1/3 area of the base times the height, or you could simply go straight to 1/3 pi r squared height. So that's 1/3 times pi times 0.5 squared times a height, which is 1.2. Now, if I work that out on my calculator, I get 0.314 ... which is approximately equal to 0.314 metres cubed, which is, we were told to give that to 3 decimal places. Okay, first part done. Now let's have a look at the second part, part B. What is the depth of the hole correct to 1 decimal place? Okay, so you need to understand this question, that the volume of the hole must be the same as the volume of the cone that we have just found out, because the dirt from in here simply changed shape, but it's still the same amount of dirt. So the volume of our rectangular prism, this one here, we know that is 0.8 times 1 times d, because that's how we find the volume of a rectangular prism. And the volume of the cone, well, we already know that from the previous question. And I might use my full calculator version, but you can use your rounded version if you like. So let's have a look at it. 0.8 times 1, if I do that part first, I get 0.8 d equals 0.314. And now I'm just solving a very, very simple equation. I'm going to divide both sides by 0.8. And so I end up with d equals, and my calculator gives me 0.3925. And I'm going to read the question again to see what I'm meant to round to. What is the depth of the hole correct to 1 decimal place? So rounding this to 1 decimal place, there's my first decimal. There's a 9 after that. So this is 0.4 meters. I hope this all makes sense. I'll see you in class.